thanks everybody for staying awake through the whole day. That's kind of an endurance situation here. I appreciate that. This talk is going to be a little different than most of the talks you've seen here. This is going to challenge some of the basic underlying assumptions that this entire industry deals with, and pushing definitions and changing perspectives. And whenever you do that, that gets a little fun. But let me ask you this question. What's the most valuable component in a storage system? The data. Very good. Why is it then that the entire storage industry ignores what it's storing? Has no idea. This is what we purport, is that computers are kind of stupid. I never get any argument with that statement. They really have no idea what it is they're storing. And we contend that that's a root cause of hundreds of problems with computing costing the world billions of dollars. Now, is that true? Is that really true? Can we do anything about it? Yeah, we can actually. So what we're going to cover today is kind of a review of what the storage industry is at a very high level. We're going to step back and see how that works. We're going to change the perspective to the end user, because that's kind of the reason we're here. And they do all the work. Now, what do they want? We're going to actually define what unstructured data is. Anybody know what the current definition of unstructured data is? Data that's not structured. Yeah. C, unstructured. That's really not very helpful. So we're going to give that a formal definition. Then we're going to propose a fourth class of storage we call the information bank, and how storage vendors can benefit from that, and then kind of lay down a challenge to the storage industry, and that is, should we understand what we're storing? Is that something we ought to be doing? Now, let me give you a little warning. I don't know why it is, but storage people have a very difficult time changing perspective. I understand that it's been, you have one perspective and now I want to change it. It's been there for 50 years and now we got to change it to the end user. We're kind of disconnected from the end user. So I'm going to speak on behalf of the end users here and try to show you what they believe. It is going to require that different perspective, and whenever you change perspective, that's a mental challenge. So don't underestimate how it can be frustrating to do that. I am also going to expose some of the problems our industry has, and that's always dangerous to do. But if you don't know what the problems are, you can't fix them. And if you go on the premise that this is a completely new class of storage, and you want to find out what it does, that's the quickest way you can shift that perspective. So that will help. I think it's worth the effort. My background a little bit, I've been in the storage industry for 40 plus years. I've earned this gray hair here. Started HP, did a lot of work in operating systems and file systems, and did a lot of file migration work, did some startups. Went and got my MBA so I could actually talk to business people, formed a startup, did all that work, did a ton of consulting. And when you start looking at hundreds of companies, you start seeing big gaps. And you get a deep and wide understanding of how everything works or doesn't. And you see this big gap, and that's what I've tried to fill here. So what's the state of our current industry? From first principles. Well, about 50 years ago, design decisions were made in the operating systems about what storage was going to be. And that really hadn't changed much in 50 years. And you get blocking files. Objects are a little weird because they're not fully integrated into the operating system itself, but they have the same issues. So what we build is plug-compatible peripherals. There's plug fests going on right now. That's okay, but that has some limitations. Our strategy here is that, and you'll see this if you take a look at the agenda, It's bigger, faster, cheaper. And that is kind of been driving the whole storage industry for 50 years. I'm not saying it's bad. I paid a lot of mortgage payments with that, so it's, you know, it's not a bad thing, but it does have some restrictions. And if you break out of those restrictions, there's some fun things we get to do. Now, this is always a fun slide. These are some of the consequences of the plug-compatible peripheral model and the 50 years of doing block and object and file. And we're going to dive into each one of these. There's some white papers available for all this stuff. We had kind of a disaster with that. If you send me an email, that'll be in the slides, the contact. Send me an email, you want the slides, I'll figure out a way to get them to you. There's quite a few of them that talks about all this kind of stuff. And boy, this costs end users a lot of money every year. And I claim we ought to take a look at that. Now we're going to dive into these a little bit because a lot of times these are something that storage people tend to ignore or are so far removed from the clients that you don't appreciate what's going on here. So some of this is my bad attitude showing through, so I'll give you a warning about that. But if you take a look at what unstructured data, there have been studies, about 20% of the data that's stored is valuable. And, you know, problem is we don't have any clue what 20% is. We don't have a way to find out. You know, that requires us to work on 100% of the data. We have to assume that every file we have has the same value as everything else because we don't know the difference. And how many people diligently do a 3-2-1 backup here? Yep. Nobody does 3-2-1 backup here. Okay, good. If you do that, that means for every unit of valuable data, you got to buy 15x the capacity for that. Now that's great if you're a storage vendor, but not so much if you're the guy from Seagate over there laughing. Sorry. It's not so much if you're an end user. And what about AI training on that? You got 80% of it's garbage. You know, AI training is garbage in, garbage out, right? So we're going to talk a little about that later, but God, what if you're renting that space? What if you're storing that on the cloud and getting charged every month for that? If you take a look at those numbers, that's a probably $1 billion overhead right there. And that's just the first item. Another one is the static and dynamic configuration. Since we have no idea what's going on, we have no way to know what to set any of this stuff to. We have to set it kind of wide open. There's a lot of things about access controls and all that kind of stuff, and that's coming up, but we just have to do it wide open. And again, these are quotes from end users. They'll go, I can wipe out something important on bumping the mouse on the way to the bathroom. Is that really how we want them to protect their valuables? Maybe not, right? How many people here have heard the 7 A's of security? Anybody? Yeah, this is what the security policy is on just about every file on the planet, including your laptops, if you think about it. That's anyone can do anything, to anything, at any time, from anywhere, anonymously and accidentally. Now, how do you make that worse? That's like going to your bank and all their cash is in a table in the lobby. You know, would you make a deposit? You'd make a withdrawal, I know you, so, right? I would too. You know, that's not the right baseline for security, okay? Because of that, if you assume users are supposed to use that, you have to assume they're a perfect user. Raise your hand if you're a perfect user. Any perfect users? Yeah. No, I said not perfect jerks, okay. Perfect users. No, we'll get back to you on that, okay. When's the last time you heard anybody go to an ATM and entered a typo and lost all their life savings? Never. That never happened. So if data is valuable, you ought to protect it. Now, what's the primary reason people store a file system? It's so they can locate it later, or they or somebody else. They can use it later. And wow, we're really limited on helping people that. If anything is even close to being accurate, some of the estimates I've seen about the cost of not being able to find a file in a system is enormous. And as one guy said, well, again, we're bigger, faster, cheaper, right? Faster ought to be more valuable. And yet customers say, okay, you can give me a nanosecond. If I can't, it takes me 3 days to find this stupid thing, right? I could send it in Morse code to the guy and he'd be happy. So we're off a little bit on that one too. So what about manual labor costs? I think this is funny. Computers have automated dang near everything in the planet except one thing, running themselves. And why is it that we have to have highly paid manual labor to run computers? All of our products in this industry are assumed to have an IT person to install them and configure them and test them and upgrade them and make sure they work with everything else. And maybe we ought to take a look at that, because what's the most expensive component of a storage system other than the user's data? It's the humans necessary to keep it going. Okay? So what about the 100 GUI problem? Well, God, ever since I've been 4th grade when I started my first company, is it a good idea to give a 10-year-old a power saw and a wood-burning set? I'm just asking. Anyway, they've had to have it beaten in me. You got to have a complete solution. If you don't have a complete solution, Bruce, you're never going to sell nothing. We don't have any complete solutions here. Every product we have requires additional products that have to be integrated together. And, a lot of people like to compare this to the steam engine evolution. Steam engines require a significant amount of maintenance. If you look at the Wyoming map, for example, on I-80 in the west, you'll see towns that are equidistant apart. And that's how far a steam engine could go before it needed work. And so you can still, it's a mess. So, are we at that stage? Getting close. So what about the integration duplication that has to happen? We have all this stuff that every data center has to do that integration. We have to pay highly trained, rare people to do that work, to do all that integration. And they have to deal with all the consequences, all that kind of stuff. But if you take a look at that, that's a tremendous amount of duplication across the world. Okay? Now, are any of you in the backup industry, just by chance? If you find somebody, thank them for their service, because they're getting screwed more than about anybody out there. I've been in that area. If you actually sit down with end users and ask them, what is your requirement for maintaining the integrity of your information? This is what they all come up with, is that if something changed and it was supposed to happen, make a copy of it. If it wasn't supposed to happen, put it back and do it right away. Everybody comes up with the same thing. The problem is we don't give backup the ability to do that. So none of today's backup systems can actually meet that basic requirement for information integrity. Just kind of sad. Okay? And here's another one that took a while to figure out, and that is we have the wrong definition of information, especially unstructured data. Yeah, that's really true, and I claim that is the root cause of all sorts of stuff. So, okay, what is it? What is unstructured data? Another thing I want to mention is there's a lot of features that, additional functions you can add on top of storage that deal with unstructured data. I did not know there's 100 different categories until I wrote them down. And these anywhere from access controls to zero trust and everything else you can think of in between. Some of them are features built in the OS, some are complete industries. But after going through the analysis of all that, I worked in companies that built all that stuff, it becomes very apparent that every single one of those categories and every product in each of those categories is hindered because they don't have a clue what they're storing. One of them fatally. Anybody know what that one is? That's the ILM HSM file migration market, because it's so difficult to tell what to migrate to and from and when is it safe to do that. All right, so we're going to shift the perspective over to the actual end users. And those are the people who are trying to run their lives and their businesses with your technology, with the storage we're given. They're responsible for that big pile of unstructured data we got out there. These are the people that have 1 million ultrasound images, or 100,000 documents for a city, or device master records for medical device manufacturing. And they're the ones that know the importance of that data. They understand what it is. And historically, like I said, we've been pretty separated from end users. Of all the consulting work I've ever done, I've never actually bumped into it, with one exception. The storage people were talking to actually end users. And that was Quantum with their StoreNext file system tied to video serving. That's the one example that they did that. But that's the one exception I've been able to find. If you do ask them how we're doing, wow, you get an earful. I got some funny stories about that sometime we'll share with you. So you ever been back-fisted in the chest by a customer? Yeah, they'll tell you, okay? So what do end users want? Now let me shift over a little bit to my consulting practice, and this is what I tell people when they say, yeah, go out and find out what the users want and we'll build it. If you ask users, they'll whisper partial riddles of paradoxes to you. And that's kind of what you get. So I use that to scare away some of the managers who think that's an easy thing to do. If anybody's ever tried that, you know the challenge there. So it does require a rather lengthy process to figure out what do they want. You know, let's dig down and find out what they really need. And that's what we've done. And we've come up with like 17 different requirements. There's a white paper available for that. But these are the top 3. And the first one's a deal breaker. You got to understand my information and its challenges. If you don't, that's a non-starter. If your transmission blows out in your car, where do you go? A florist? No, you go to a transmission specialist. IT people can't help them because they don't have any idea what they're doing. You have to understand the dynamics of that information as well, and that becomes a little harder. You got to know that things can change, and abruptly and instantaneously and dramatically. So keep up. And here's the other thing I found out. I can't understand why they don't want to be IT people. They don't want to even hear the buzzwords that we use. They don't want to know any of that stuff. They don't want to be asked questions about stuff they can't answer. And they'd rather not have to hire somebody who has figured that out, because that's expensive and rare. So those are the 3 key things they need. Now, here's the most important slide that we came up with, and that is, what is their definition of unstructured data? Okay? Now, again, they won't tell you this directly, but this is what we discovered, and that is their unit of information is a collection. It's not just a file. It's a collection that is meaningful to them. That can include a file, or it can deal with hundreds of files. If you're doing an ultrasound scan session, that could have 2,000 images in it, but that's their unit of information. It can have things like attachments and emails and people and tracking data, all the metadata and notes and reminders and the whole ball of wax that they define as their unit of information. The most important part of that definition, though, is that it's driven by a governing life cycle, which means that stuff changes. And you have to understand how to handle those changes. Because if you do, that changes a lot of stuff. This allows us to do and fix hundreds of those problems. It allows us to automate IT, for example. That would be kind of nice. So this is kind of a different term that I haven't really seen much in the past. Here's an example. I use a contract as an example. What is that? What makes up a contract? Well, it's more than a Word document. It's all this other stuff that's out there. The templates that come in, the tracking data, what kind is this, who's it for, is there a job number with it, for example, and all that kind of stuff. So to meet those requirements, what we came up with is a thing we call an asset container. And I came up with the term information asset. That's the only term I came up with. Everything else is driven by the end users. So what we came up with is this asset container. It's a collection of assets with the same requirements. And so it's based on certain design processes. In this case, a design process would be fixed content, which means you don't get to change anything. Or it may have a check-in, check-out, or it may have a revise, approve, review cycle, or any number of those. These are configurable, it has metadata and all that kind of stuff. And they're reusable across all sorts of properties, companies, and industries. We had one client that was ultrasounding cow rear ends. And I didn't know that was a market, but apparently it is. And they have the same problem everybody else does. The nice thing is that those design patterns, while they're difficult to generate, there's a limited number of those, which is real handy. And so what you do is you take those and then you use those as building blocks and tie all the pieces together. You provide a way to do that. What we're working on now is a language called Equal, kind of analogous to SQL, that lets you set up all this configuration very easily. Okay. If you've ever done database work, you see what, on an entity relationship diagram. Those databases have boxes there. We have triangles to show it's kind of a directory structure full of files. So in this case, we got contracts. It gets contracts out of a template. It's based on what type of contract it is. The templates, you might have to have the outside counsel approve any changes to that, so they have legal standing on that. You might have a customer table over here that says, hey, these are who it is. They might have a job number for each one of those. You might have a requirement. You have to have a customer and a job number when you create a new contract. They can have attachments, notes. Notes just a piece of text that you can throw in there, kind of like a Post-it note. And a reminder is a way to set some event way in the future so that you have that asset come get you, and we can prove that you heard that. So that, for example, if it's a 2-year contract, hey, 18 months from now, come get me. And say, do you want to renegotiate that contract? Do you want to cancel it? Do you want to let it lapse? Whatever you want to do. And then when they're done, you could have a place to archive them off, and you can trigger other processes, et cetera. This is a fairly simple setup. There's also a whole bunch of other things you have to track for that. You might have statements of work, non-disclosure agreements, status updates for that, contract completion requirements, all that kind of stuff. So you can build up fairly complicated processes with just the basic building blocks. Okay, now what is the product that implements that? And this was named by the users. We call it an information bank because it's a place to store my digital valuables rather than my financial valuables. And it's a very easy concept to understand. It's kind of trivial to explain to people. You say, oh, you make a deposit. Cool. The bank takes care of everything else. Great. I can teach my grandfather how to run this. Perfect. And what it does, it implements the information asset model and those containers as its native data type. So that's what it operates on. That's how it handles it. And it drives the dynamics of that situation. So it knows is that supposed to happen or not? It actually knows the future, which is kind of fun. It has some enormous advantages. It allows us to solve hundreds of those problems, including all the top 10. And we can kind of automate the IT portion of this, which is kind of important because, not completely, because, you know, right now it's either a device or VM or containers that sit on the cloud, so you got to deal with a network. And you'll see in a minute there's a client that needs to be installed. But once that's done, the system can run itself, it can update itself, it can audit itself, it can fix everything, it can change it, whatever. And it's an interesting platform for technology integration. So if you need to have, you want to have something else put in there, if you have a particular client that wants something weird, it's flexible enough to do that. Okay. So what does the topology look like? This is a quick example of this. The center of that is the bank, and on the left is the clients. There's an installable client that's pretty simple. To access the files, we have two different ways right now. One is through the CIFS to access the files, and we still use our socket protocols for our interaction. If you don't have CIFS or you're the other side of the planet, you want to remotely access that, we do all the cache coherency and locking and all that good file transfers and stuff. So it behaves very much like your local, but it doesn't require CIFS to do that. If you're an NFS aficionado, we don't currently support that, but if it's needed, we can go in and, because the NFS has some limitations about knowing what's going on, that would have to be a kind of a hybrid of what we call a web client and the normal file transfers. We also have a browser only, so you can do search and download, pretty simple. One of the things the bank communicates with is what we call a central bank, and that's another bank that does things like escrow the configurations, and it's a certificate authority for all the certificates and things like that. Handles updates and support and log transfers and everything. The intention here is the central bank can handle a lot of different banks, so you can manage a lot of these things from a central location. That's in the cloud right now. And then the banks use a database service and an object storage service to mirror the information assets. And it does that just like it says. If something happened that's supposed to happen, it updates it, encrypts it, sends it up to the cloud so that anything happens, they can restore it. The intention there is if the bank goes away, you can put an empty one there, restore the escrow from the central bank, load in all the database information, and then dribble in all the files as you need to. So you can recover these very quickly. Another thing we added was what we call a shadow bank, and that allows the data that was put up in the cloud to be brought down into another location. That can be anywhere, be running on a different location, a different continent or whatever. And the nice thing about that is the banks and the shadow banks don't know anything about each other. We use the object storage and the database server as a barricade between the two. And if you set up multiple shadow banks, and a shadow bank can have its own shadow bank, and most of those are turned off unless they're synchronizing, that makes it really hard for a criminal to wipe out your data. We call that FDIC, because if you explain, you got an information banking, explain it to anybody that understands finance or banking. That's one of the first questions they ask you. Well, what is FDIC with that? Okay, well, you make a lot of copies, you store it all over the planet, make it hard for them to find. All right, so let's take a look at what the bank looks like. It's standard Linux with a file system underneath that. It has CIFS, Samba, that kind of stuff. As a SQL server, we use Postgres, no big surprise. Got a search engine, our Saga protocol and a web server. Those are common stuff. The things that are unique, one of the things is the watcher. We actually monitor every file and every directory of the user's information to tell when something happened, whether we did it or somebody else did. So we can detect that immediately and respond and do that right. That's kind of a tricky little algorithm to get right, because you get an enormous amount of data from the loggers that are in these file systems. The next thing is kind of the rules engine, and that's the core of this technology. It's event-based, and events are business-based, like, hey, I want to request approval for this contract. And each event is a sequence of behaviors, and the behavior is some single function that it does. So it does some validation, might copy a file, might update the metadata, et cetera. And so that whole sequence implements that event, which is, think of it as a command or something like that. The tricky part about that is getting the threading model right, so it matches how OSs and file protocols and file systems work. And it's really designed for reuse and flexibility, so you can add in more behaviors if you need to or adjust accordingly. And we call that base. I mean, structured data has ACID. We call this base, behavior actions of synchronized events. We'll come back to that in a minute. Okay, so went through that pretty quick, but it has some clear advantages. Process automation for end users is the entire reason we're here, right? Sometimes we lose track of that, but that's why we're here. We can deliver that directly to the end users. That's kind of the reason we do this. It can also solve a lot of those problems that I covered, and there's many more that we really have. I tried to write down that whole list once, and I stopped after 45 pages. Couldn't take it anymore. They don't have enough medication for that. The other part of this is that because we know what's going on, we know when to do things, and we know when to do them, what to do them on, we can pretty much eliminate the need for IT support. Not completely yet, but I mean, these systems run a year without anybody looking at them. So, and like I said, it's a platform for technology advancement, because I've seen this, I've been coming to these conferences since before there was SNIA, and every one of them, there's some technology would be really handy if we had that, but we can't do the systems engineering to integrate it, because we don't know enough about what's going on. We don't know the intent of the user, for example, and this you do. Plus, the nice thing is nobody believed I could do this until we built it, and so now we did. So there's an existence proof. And if you're a storage vendor, a distributor, or MSP or something, that has some distinct advantages to all the different departments in your organization, all the way from the CEO down to support. If the system self-audits, self-repairs, and all that kind of stuff, and calls you when something's needed, that really reduces your support costs. Plus, you can have the CEO can have a nice little top line, bottom line, simple strategy that every CEO on the planet likes, and everything in between. So here's another approach, another way to look at this. And if you take a look at what structured data has, it has a formal definition of it. It has systems to hold it, database management systems. It's based on set theory. It has tables and ACID and views and triggers and stored procedures and lines and tigers and everything, including a language that is fairly easy for people to do. It's been very successful. There's standards, there's dedicated industry for that. So that's been working really well. This will elevate unstructured data to the same level. We'll have a formal definition of it. We have an information bank to put it in. It's based on parallel synchronized events. It has containers. It has, like I said, base. It has views and triggers and stored procedure. It has a language called equal that does the configuration and that kind of stuff. There's an opportunity for standards. There's an opportunity for an industry. Banks are highly regulated because we're dealing with user valuables. Is there any reason to believe that information banks wouldn't end up being regulated? And what's the two assumptions that regulators make when they want to put regulations on your data? What 2 assumptions do they make? Anybody know? Anybody awake? Raise your hand if your pants are not on fire. Okay, great. Yeah, you're going to get sued. Yeah. Yeah. No, the one thing is, you know what your information is, and you can control its behavior. Does that sound familiar? That's the 2 things of an information asset. So with that approach, you can protect yourself from all the crazy stuff that seems to be coming out of Europe, doing all the regulations and stuff like that. Okay. Now, it's really funny. I've been involved in these kind of things forever, and every new technology I come up with has what we call traps. The first 2 are funny. That's it. If somebody, what's it like being an entrepreneur? And I walk up right to their face and I go, that'll never work, and you're an idiot. That's what it's like. Okay, there you go. Yeah. So those are always the first 2 traps. Now, a trap is something that looks obvious. It's, intuitively obvious to the most casual observer that that's true. And if that's true, this whole idea is trash, and let's go to dinner. The reason they're a trap is that if you go test that assumption, you find out that's false. No, that's not the way it works. And because this one has such a wide scope, this is the most traps I've ever seen. Here's a few of them. Yes, it does work. Bruce is not the biggest idiot in the universe. Don't ask my wife about that one. But you don't need to change anything in the operating system, the file systems, the storage protocols, or anything. That allows us to add this to existing systems independent of all these other vendors and operating systems and companies. Yes, the information owners do know way more about this than you do. And that's kind of an ego-smashing thing. And if you haven't actually thought about the whole information asset idea, you haven't seen any yet. But now that you do, you're going to start seeing them everywhere. And I claim every single file out there is part of an information asset, whether you know it or not. You got to know what it is. Right there, that's an information asset. There's nearly an infinite number of the different information assets that people use. It's stunning how many things different types of information assets people have to work with. And any one of them can have an enormous value and risk. When I first started this, there was a guy, an IT guy I talked to, and he said, this is before I had anything even started, and he goes, I could have justified the purchase of your system with one file. That file was the maintenance agreement for that big storage device that just blew up, and nobody renewed the maintenance agreement on it. So we had to go do this giant emergency file, dollar transfer and get the crowbar out so that you can get money out of the CFO to pay for it. And they had to buy a new one rather than renewing it. That was very expensive and took forever. And it's kind of, maybe you can, but I haven't heard a lot of products you can justify with managing one file out there. Okay. And here's another thing. Your processes are not unique. Yes, they can be built up with all these components. There may be some tweaks we got to do, but there aren't a lot of unique processes out there. This is one I run into all the time. There's a white paper that has 36 of these things. So before you junk this idea with an assumption, go check that list first. So what can that mean to our industry? We now know what the data information is, we know what its requirements are, and we can now make differentiated products and new products lines. And we're integrating a whole bunch of stuff together, including backup and disaster recovery and security and the whole works. And so you can get higher margins for these things. And new markets, new banking services that we haven't even thought about yet. New product topology. Banks talk to each other. A lot of times these storage devices really can't talk much about each other because they have no idea what they got. If you did, you'd be able to, all the migration problems would go away, right? Sure, that'd work. Yeah. But it's kind of a foundation for kind of a growth in our industry. And one of the interesting things I've done in my career, about 6 times, believe it or not, is how do you deal with file migration and the file tiering and ILM and HSM, whatever they call it, this incantation. That's been resurrected and died about 6 times during my career. Now, one of the problems we ran into is how do you know what you can migrate, and how do you know when you can migrate it? And in hindsight, what we were trying to actually do is take what was available in the file systems and the files and try to create some form of information asset out of that so that we could make that decision. And it turns out there's obviously exceptions to this, but it turns out the information you need is not even in the computer. You scan the file system, you get the last access times and stuff like that, and you looked at it, so you just updated the last access times, right? The file name, it's not even in the file. It's simply not in the computer. It's also not in humans' memory. Meatloaf memory has a pretty high failure rate. So they don't remember what it is either. So, and then what do you do? Okay, how do you make that decision? Well, we couldn't actually do it. And that was that and a few other things was one of the key things that caused that ILM to let's say didn't realize its full potential. Right? If you do migration at the information asset level, you know the business process. You can set business rules to migrate things. Hey, any of our invoices that are over a year old that we audited, migrate them out. And we save off the metadata about it and the logs and the search and stuff, and we only put the files out there so you can still access and see what's going on. That just opens up a lot of opportunities on the file migration side. Now, what about AI? If you don't use AI in a presentation, I guess they don't accept it, so you got to have something about AI. Well, it turns out AI is trying to do the same thing. They're trying to read this pile of files and try to make some sense out of it. They're pretty good at content. That if they read they know what a contract is. They can summarize that kind of stuff. But there's a whole lot of other things that they have to do that are very difficult. Like if there's any data there. If so, where is it? Is it valid? If you got 50 copies of the contract out there, which one's correct? All the others might be wrong. You got its identity, you got its history, you got all of its metadata, you got its context, where it is in its life cycle. You know what the life cycle actually is. And you also know the relationships amongst all that information. So you know this non-disclosure goes with that contract, that goes to this RFQ, that goes with this whatever. And I'm quite a bit more pessimistic about how AI is going to solve that problem, because I've personally tried to do that, and without a lot of success. That's kind of the impetus for this. Okay, what do we have to do if we want to know what that is? And that's what started this whole thing in the first place. AI and data scientists struggle with that. It's the whole cleansing, identification, location processes you've been hearing all week here. And they're trying to determine what all that is. And that's an ongoing struggle because that pile of files keeps getting bigger and keeps getting updated. So what I'm considering is that if AI was a user of the bank, if it could extract the information out of the bank and do the training on the information assets. It has the log histories and who did what when and the changes that were made and everything. I think they could do a much better job of training their system and provide better opportunity. The other thing is that if they're a user of the bank, then we can tell what data it used to train and when. We can prevent things that are under NDA from a vendor from going to the training system. And likewise, if the AI is asked, hey, create me next quarter's marketing budget, well, now it has a place to put it. And it also has a process it can go through in the bank to make sure that it is following the right process, that it's using the right template, it's providing the right required metadata, it's putting it there so it's safe and protected. And the, protecting information from AI is not something I've heard yet, but I've heard that from end users. They go, you ready to let AI go scan everything and take over your business? And they're going, yeah, I don't think so. This can provide that kind of protection. Okay, so we kind of wrap up here. Who's us? We're a small company. It's Bruce and his buddies. We're self-funded. We have the information bank. It's been in production. It's been in customers' hands. It's proven out the technology, but it turned out to be way bigger than we thought it was. So we're at our company, we're trying to figure out how to move forward. So we came here and say, hey, let's do this. So again, switching over to the consulting practice a second. This is the sequence I train people if you're going to take some external technology and integrate it to your company. You go through these sequences. I have to say that the prototype needs assessment. If you're going to build a prototype, that's where most of the time I see failures. So I just say, warn yourselves about that. Okay, that was a word from our sponsor. Sorry. So where do we go from here? And that's, this kind of needs industry-wide, because I believe that the more we know about what we're storing, the better job we can do. And that's going to kind of end up deciding what we're gonna do. I think SNIA is the right organization to drive some of this stuff. To facilitate that, there's a bunch of white papers, and again, if you want to know what those are, I'll send them to you. You can get access to the product and so on, whatever's appropriate. Okay, so it's kind of a call to action. Now you know what the problems are with our basic assumption of bigger, faster, cheaper. Now you know there's a solution for the consequences of that. Now, okay, what should we do about it? That's not an easy question to answer. So it does require further discussion. I think that's an understatement. So we're gonna have a birds of a feather. It's gonna be, I think it's next door. It's at 8 o'clock in the printed manual. It talks about, it gives 7 o'clock. It's actually 8 o'clock in the next room over there. So I believe this strongly that there's a giant need for that. We don't have a lot of customers and we're pretty small, but every single customer has come back to us and said, we need something else because this impacts the way we run our business so much that we're willing to pay for the development of that feature for your product. And that's a good indication that's working. There's one guy who did it 11 times because it made such a big deal about how he was running his business. Another one was a 6-figure development contract because they simply couldn't find anything out there. And another thing I wanted to mention too is that lots of different functions out there like accounting and engineering and mechanical engineering, they all have some main piece of software they run. Accountants run accounting software, mechanical guys use SolidWorks or AutoCAD, electrical guys have that. Software guys like us, we have IDEs and GitHub and things like that. We're not saying to eliminate, we're not going to replace those. Those are highly tuned for their process. The problem comes in is what about all the other information assets that you have to deal with that surround all that stuff? And that can be extensive. Like I said, some industries just don't have anything that's worthwhile. I mean, if you say, hey, I got a lot of NDAs here. I need something for NDAs. What do you got? And you can take a bank and very quickly give them what they need at a much lower cost than any OPSEC development or a product that was designed specifically for that. So anyway, that's kind of what we're talking about. Now I recorded a webinar demo of the software has a couple of user errors in it that you get a laugh out of. But that's the, go to our website /demo.mp4. There's not a link on our website for that. You have to type that in, but that'll show you what we're talking about. So, all right, that's kind of what we got. Thank you. Any kind of questions? Anybody still awake? This is a long day, man.
Anybody ever asked, like, is there a blockchain angle to this, or did you deliberately leave that out?
Our process for technology is we'll build what the customers are willing to pay for. We've looked at that. One of the interesting things, if you're in the construction industry, especially commercial construction, at the end of a construction job, everybody sues everybody, right? And so I think when the Denver airport was built, there was like 384 lawsuits. All the construction guys saying, you can't prove that I was told you to take down that wall, so we're not paying for it. And you run into that kind of crap. And so what you want to be able to do is put hash functions in a blockchain and be able to prove to the judge saying, no, that was the file, that existed at this date and time, and yeah, it says in the log, that guy approved that. And we got it right here. So, yeah, the answer is, have you thought about, and then insert your favorite technology? Probably, and we have a way to incorporate that if it's necessary. Yeah. So.
I have a couple questions on,
yeah.
a lot of things that you described kind of reminded me of when I was at Kubernetes conference, and the guy described storage as Kafka.
Storage is?
Kafka, a broker.
Oh, okay, yeah.
Right? So it's a lot of what it sounds like you were describing was putting a broker in the middle and people having topics that they're publishing on and then being able to have triggers and events and do things afterwards. So it's a data pipelining solution to storage as opposed to putting rocks in a box. Data is liquid flowing.
Right. Yeah, it's same spirit, I think. It's slightly different. I mean, the life cycle is really kind of a pipeline instead of a piling system, so that you can actually delete things off the end of the pipe, and you can, things like, hey, anybody ever changes this file, let me know, and you can do all that kind of stuff in our thing too. So.
SNIA became the regulatory agency. What would be the minimum viable solution that they would regulate?
I think it would have to be around the similar things that you do with banks, is that you have to prove that you don't lose anything. You have to prove that you can keep things identified. You have to prove that if the access and security, which are kind of both ends of the coin, that when you set those, that's what you actually do. And I don't know yet. I mean, that's part of the discussion. I don't know that yet. I'm just saying that if you're keeping users' valuables, you kind of need to watch out what you're doing. So, okay, thanks everybody. Yeah, thanks. So, that was the most anemic clap I have ever seen in my life. Thank you. Yeah, everybody's all burnt out at the end. So.